In this video, we are going to learn about AI agents. We will understand what do this AI agents basically mean. Then we will understand how the LLMs versus the AI agents differ. Like what are these AI agents versus what are this ChatGPT, Gemini, all the different type of LLMs that we use. After that, we will understand what are the different components that makes an AI agent. And then to see them all in action, we will actually implement with the code through LangChain some basic AI agents. So let's get started. So first thing, what are the AI agents? Now in ChatGPT or Gemini, you may have tried certain things like help me generate an email. You got a content, but now you have to manually copy this and into your any mailing systems. You say that okay, help me create a report. It may create a report and then you have to copy paste it and put it inside the Word document manually. Similarly, like you may also say that, okay, these are my database schemas, help me create a query. Now, this thing, when you're doing in ChatGPT, it is able to do it very well, but you are still involved as a human to take it out and then run through it. So the systems are purely generative in nature. They can generate, but they cannot take any action. I'm talking purely about the LLMs. So LLMs are pure generative machines where they take the prompt as an input and generate some output, but they cannot go beyond that. They cannot take any action. To make actually the actions come into picture, we have the AI agents. AI agents are more of LLMs with superpowers. Okay, so what do I mean by that is now to the AI agents, we will assign certain tools, and through these tools, it will be able to access the real world, like the emails, databases, APIs, browser, web search. It will be able to access all of that and gain access to the real world. Okay, so that's what this AI agents basically means. These are like extended version of the LLMs, where LLMs can understand the real world very well, but AI agents take them to the next step. If you have to see structure in terms of how this AI agent works, what really happens is just to give first an analogy. See, we as the humans have a brain as a supercomputer that works with us. Everything goes through the brain, but we have all these organs, senses through which we try to interact with the real world. So what happens is even if I have to move my hand up, the signal first go through my brain and then I'm taking a step. So everything goes through the brain first. Okay, like even when I'm speaking, everything is first getting generated in the brain and then it is coming. So everything happens through the brain. In the same way, LLM plays a very important role in terms of a brain. Okay, AI agents use this brain to make all the decisions. For example, we will give it access to the tools. Tools are nothing but APIs, databases, queries, all the different digital elements or code execution engines. We will be giving it access to the actual code or digital elements where executions can happen. LLM will give us the steps. Okay, for example, if I give it a schema and say that, okay, generate a query and execute it. So within tools, I can define some APIs. And through these APIs, AI agents will ask LLM that, okay, so this is a problem statement, this is a schema, you generate a query and tell me how do I execute it. LLM will be able to give it steps. AI agent, based on the available list of tools, can actually execute those instructions, send it back to the LLM and verify. Patsy, this is the query I executed with the database through the tools. Now, this is the output. What do you think? Is it valid or not valid? LLM will say, okay, this looks good. No, we don't need more information to solve this question. So it will check more details, create a new query, send it to the tools, get the output again, and validate. So it's an iterative process where it's not just one single iteration, but it's a iterations, multiple iterations through which the user's query is resolved in the AI agent. Okay. Then on top of it, we have this concept of memory. Now, memory is there present because LLMs are stateless by nature. So when I say stateless, every request is completely new to the LLM. LLM don't remember any past conversations at all. Every request is just a tokens or prompt as the input and some text generation as the output. So memory maintains all the previous conversations. Okay, whatever discussions we had done till now, everything is maintained as part of a memory. Then we have a planning stage. Now, planning is all about how do we execute a step. For example, if you have used the code ID, like agentic IDs, like GitHub Copilot, Cloud Code, and all those different tools, what really happens is when you give a certain instruction, it first plans, saying that, okay, I need to create this file, I need to make changes to this file, I need to create this one file. It comes up with all the steps that how it should solve the given problem. And then one by one, it starts solving them. So that's where the planning plays an important role. So this is at a high level how the AI agent works. Now we will go and execute some code to see them in action. Now let's get started with the code hands-on and see how this AI agents actually works. How this AI agents, LLMs, tools, all they interact and give us the access to the real world analytics. So first thing, I've already defined an access to the Gemini object. You can see the previous video over the link to see how you can create a Gemini key and access that using the LangChain. So I already set up the object here. So what we will do now is we first we need to install the library, and then we have to set up this key. Once the key is set up, we can see that the LLM is responding. Okay, so this is like how LLM gives us the response. Now let's see this LLM, does it have access to the real world? So when I say real world, what is the current date? Now, if we ask a current date, it says the date around in 2023. This is where this model was last trained, like this, like around the cutoff date for this model. So it is limited to that date. If it actually is hallucinating in terms of the date, if I run it multiple times, you will see that it comes up with like lot of different dates. So this is not access to the real-time data. It is only coming based on its own learning. Now, if we want to give access to the current date, we have to do it through the AI agents is one of a way. Now, what we can do is we will go to LangChain create agent. Now, this is the agent documentation. So what we will do is we'll first copy this create agent and definition of the agent object here. So first is this. This is going to be converted to the LLM object which we have already created. One thing is we need to define the tools now. To define the tools, now tools are a way through which the AI agent will give LLM access to the real world. Okay, so how that really happens is let me come down to this part and I will copy this tools statement. Now, this tools we have to create it as a decorator. Like we have to define a function and attach this tool as a decorator, then use it. So first thing, let me define a current datetime function in Python. From datetime import datetime and define get current datetime. I have to add a document like doc string, which basically says what is this function going to do. So this function returns current date and time. So what we will now do here is return datetime dot now. Let me also test this function. So once we create this function to test it, so this function is working and giving us a date time. Now, to transform this into a tool, what we will do is we have to add this tool decorator. And once we add a tool decorator, we can pass it as a list of tools. Okay. Now this is creating the agent. Let me see what is the issue here. We are missing the code. Perfect. Sorry, the code is actually not needed. We have to only give the object. Done. Now, in terms of agent, now this create agent is a LangGraph object. More about LangGraph over the future, but LangGraph is like when we are invoking, it is slightly different when we are invoking it. So we have to pass a dictionary. This dictionary is like a state. We call it a state. More about that later. But for now, the syntax remains same. So we'll say messages and list of messages we have to give here. Now I can ask what is current date. Okay, let me just go with the date and we will capture this in the response and then let's also print the response. Okay, so what you see here is when it is responding, there are multiple messages. The last message, if you see, is the current date. Okay, this is 2025 December 28th. Now, what is happening here is if you see the multiple messages, first is this human message, which is the input message that we gave. Second is AI message, which is LLM's message. In the first message, what really happens is together with the message, all the tool definitions are also sent to the LLM through the agent. The agent will call the LLM with all the tool definition that these are all the tools that I have access to. This is a question. You tell me whether we can use this tool to answer something. So then LLM says, okay, so based on the available information, function calls, this is a function that you should execute. LLM do not have access to execute any function. It tells the agent. Now, agent will do the activity of executing the function, getting it, and sharing it as a tool message. Okay, so it says that, see, this is a tool message. This is what the output I've got from this message. Now you see whether it is useful. LLM says that perfect. Now this is the answer. Today's date is this. I can also ask what is current date and time. Okay, when I ask date, it only give me date. Now when I'm asking date and time, this is giving me date and time also. So this is how AI agent is able to interact with the LLMs and tools and create output. Okay, so where like right now the AI message is being called two times. There are two invocations which are happening. First time, identifying what tools to execute. AI agent will execute those tools and give the response again to LLM saying, see, this was the original question. This is what you told me to do. This is the output from the tools. Now you tell me what is the outcome or do I need to execute more tools? So that's the iteration which will go. So this is one tool. Let's add some more tools and see how it interacts with the multiple tools. So I have already defined some tools. So let me add those tools here in terms of functions. So we'll add like two different. One is add two numbers. Now we are also giving arguments to a function. So A and B. Now here the interesting thing is LLM should identify not just the tool name, but also what arguments to pass. So we are passing, and that's saying that this is the integer arguments. The output should also be integer, and the return is A and B, A plus B. And one more thing to understand is AI agent do not send the definition of the function. It only sends the initials of the functions, like what is the name of the function, what are the arguments, what is a docstring. It does not give access to the internal definition of the function. It only gives access to this much of a part. Based on this, LLM understand what to execute. Now, second function is the weather function. Now, interesting thing about this function is it uses the API. It takes a city, it's a get current weather. It takes a city as an argument, calls an API, and then from the API it gets some data and then showcases that data. So this is where like a external API is going to be called to get the data. So let's add this as a tools to our agent. First thing here we will add the add to tools, and then second thing we add get current weather. Okay, so we have added the list of tools to the create agent. Okay, let me see if there are issues. So there is one spelling mistake. So let me run this. Perfect. Now our AI agent is created. Now let me run this and ask it for addition. What is the addition of some longer, lengthier random numbers? Now when we run this, what you will see is now the tool that is being called is add two numbers. Right now we have three tools we have given to this. So out of the three tools, it is saying I need to execute like it is asking the agent that okay, you execute these tools. Also on top of it, it gives the arguments. And these are the arguments. It is able to understand the user query parse it into the arguments, and then call this asking to call the function. AI agent calls the function, gets the output, passes it to the LLM, and LLM then finally gives us the end result. Okay. Now, in same way, let us also see how the third tool really works. What is the weather in Mumbai? So let's see what happens here. There is something wrong. Let us see what is wrong. So it's the request library is not defined. So let me just add the request library, import request. So request is being used here. Request is used to invoke any APIs in Python. So let me run it now. We will again define the agents object. And when I come down and execute it again, so let's wait for the end result. So it's taking some time to execute. Okay, we have a result. So the current weather in Mumbai is smoke with temperature 27 degree, and this is what the result basically means. Now, to actually parse this last message, what we can do is response messages. We have to go with the last message and then dot content. Okay, so this is a messages object. This is a list. From this, we pick up the last -1, and then from that, we pick up the dot content. So I can print this now. Okay, so this is the print. So current weather in Mumbai is this. So this is what the weather information is coming. So if you see, it asks for get current weather function with the argument of city Mumbai, and then the content is coming from the tool definition, like the tool's output, and then we are getting the result. Now, one more interesting thing is the tools are not just like one tool, but we can also parallelly execute multiple tools. For example, I can ask what is the current today's date and weather in Mumbai. So let's see now what happens. So interestingly, it will be able to answer both the questions together. So how that happens is, in terms of the function call, now there will be two function calls which will be suggested by AI model. It says that, okay, now to solve this problem, I need a data from two tools. One is going to be the get weather city Mumbai. Okay, so we'll have an object called as tool call. So let me directly go to the object called as tool call. So this is a tool call object. So this is the first argument and this is the second argument. Okay. So first argument here was getting the current weather, okay, with blank arguments, get current date time. So current date time with blank arguments. And then second one is get current weather with argument Mumbai. Both the tools are suggested. And then AI agent will send the results from both the tools. That see, this is a result from the get current date time, and this is a result from get current weather. And using both of that, AI agent will be able to summarize all that data and provide a response to the user. So this is how this, again, all this LLM tools and the AI agent is working to solve the problem. Now we also discussed about a memory. Memory is nothing but stacking of these messages together. Okay, this is like a short-term memory, a short memory right now, where the memories are maintained only for a small conversation and then removed. So that's why, like, first AI message gives us that, okay, execute this tool. In the next iteration, we give all this information to the LLM to get the response because it doesn't remember anything. So next time we have to tell the LLM that, see, this is what I asked. You had told me to do this. This is the result. Now you tell me what to do. So this is how this agent communication works. Planning is more of this thing that you see as how these multiple tools are being executed together. To solve the problem, I need two tools and then get the result. So there could be a sequential activity or even a parallel activities. Okay. For example, we can ask LLM that what is the addition of some random number, and then this. Once done, you again sum the results with this thing. Okay, so let's see if this works. So now, interestingly, what is happening is first thing we asked it to do the sum of this and then give us the sum of this. So initially, this is calling for this add two numbers. Now here the numbers are 23423 and this 32423. Only two are given. AI agent gives the result. Again, AI LLM basically says that I need to now get this result and this number to be added. And then we are getting a result. So this is a planning where it is planning that, okay, initially I have to do this and then I have to do this. So this is how this AI agents work. Now, just last one more thing that I would like to add is now it doesn't mean it is only limited to the tools. It can even go beyond the tools. If it can answer something without the need of tools, it will directly answer that. How that goes is if I now try to ask it, what are AI agents? Okay, we will ask now, what are AI agents? So what we'll see is now there is no tool call. This answer does not require any tool call, so it directly goes and answers this question. Okay, so it is we are not limited to say that everything is limited to only the tools. Tools are only used if it is required. If not, it can answer based on its own knowledge. So this is the AI agents. I hope you like this concept and you understand more about the AI agents working now.